Okay, I think I'm good. Um, all right, in our last class, right, that was, I'm not gonna, I made a little, okay, I made a little uh, slight, I made a slight adjustment to the, okay, so I'm gonna download this again. Excel file. All righty. So what we're going to talk about today is comparing projects with unequal lives, right? So we've been basically now in net present capital budgeting examples that we've been using for either standalone, right, standalone project, or mutually exclusive projects, right? Mutually competing or mutually exclusive. But they were assumed to be, if they were mutually competing or exclusive, they were assumed to have same project lives, right? You remember in the so in this example, in these examples, right? In these examples, they were all see project A and project B, right? They both had 6 years. So comparing them was easy. You know, I mean, NPV, net present value, find net present value, or internal rate of return. And whichever is greater, whichever has greater net present value, that's the thing. But then the projects don't have necessarily equal lives, right? I mean, by coincidence, they may have equal lives, but project A and project B may have different lifespan. So if a significant difference exists between mutually exclusive projects' lives, a direct comparison, wait a minute, am I recording? I believe this is being recorded. So there can be no direct comparison, right? If the lives are different. The problem arises due to the net present value method. Longer lived projects almost always have higher net present value. Of course, think about it. The longer the timeline, right, there are more future cash flows, right? And those are cash inflows, right? More cash flows in the future will always result in a greater net present value, right? So how do we compare these two? There are largely two methods, right? Two methods, two solutions exist. One is replacement chain method, and the second one is equivalent annuity method, equivalent annual annuity. Now, replacement chain method, literally, it extends projects until a common time horizon is reached. Extends the projects until a common time horizon is reached. So think about it. One project is 3 years, the other project is 6 years. Then the common denominator or common multiplier is 6. So then, you duplicate the shorter-lived, right? Short-lived project twice. And then, we can compare the effect. Or one is 3 years, one project is 3 years, the other project is 5 years. Then the common multiplier is 15. So you extend both projects to 15 years, and then you can compare those, right? That's what's called replacement chain method. And the equivalent annual annuity, it's basically, assuming, those projects are, those projects can generate annual annuity, right? Which one is, so I'm going to get to both of them. First, replacement chain method, right? Which of the two following mutually exclusive projects should a firm purchase? A short-lived project has 3 years, right? Short-lived project, and the long-lived project has 6 years, right? And the short cash flow at time 0 is 1,500. The longer one has 2,600 initial investment, right? And then they have expected cash flows like this, and that's very even. I mean, this is very unusual, but to make it simple, they made these future cash flows even. Now, if you find the net present value of this, right, it's going to be 43282 at an 8% discount rate, and the internal rate of return is 23.4. Now, in the longer-lived project has the net present value of 867.16. Of course, the same discount rate. Internal rate of return is 18.3. The IRR method argues for undertaking short-lived project, higher IRR. NPV method argues for the longer-lived project. But then we'll have to correct for the unequal life using the replacement chain method. Okay. First, replacement chain method. Let's take a look. I have to. Okay. So we will, short-lived project. If we replicate this project for another 3 years, right? Think about it. At this point, so there should be 1,500 cash outflow at the beginning of at the end of C3, which is the beginning of fourth year, right? That will be seen, a little, short while. And this is basically, what we know, but you need to understand this will need to be repeated at this point, right? If you're duplicating this project, this initial investment will need to be made here as well, right? So then, net cash flow at the end of year 3 or beginning of year 4 will be negative 750. So let's take a look at it. Okay, if you're duplicating the short-lived project, right? Duplicating the short-lived project. So you see why the net cash flow is negative, right? Just cash outflow. And if you do this, net present value is 776, right? If you do this, net present value will be 776 with the internal rate of return of 23.4. What was the net present value of 6-year project, the project B? Still, net present value is better, right? Long-lived project has a better net present value, lower internal rate of return, but better net present value. When net present value and internal rate of return give conflicting results, we go by net present value, right? So a long-lived project will be picked. Okay. And then, so let's try that first, right? Let's try that with Excel first. So if you download, you may download. Oh, okay. This one is actually equivalent annual annuity. So I think I didn't make. So please download this file if you haven't, right? I didn't make that example, huh? Okay, so let's do the equivalent annual annuity. So the equivalent annual annuity method equates each project's original net present value to an equivalent annual annuity. So what does that mean? That means net present value of project A, and then whatever this may be, let's call it X. And net present value of project B, let's call it Y. And then, if this is, let's say, 5-year project, 9-year project, right? Then we want to, if this is the, this is present, if this is the present value of annuity, right? What kind of annual annuity payment will it generate, right? So for example, I mean, from this, what kind of annual annuity payment can be generated? Right? You guys know what annuity is, right? Annuity is what? Regular payment or deposit at regular interval. That's annuity. That's what you learned in Finance 100, right? And there is future value of annuity and present value of annuity, right? Future value of annuity is like, you are saving like, $1,000 every month for the next 5 years. And that's going to be 60, deposits of $1,000, right? And at the end of, year 5, or at the end of 60 months, what's going to be the total amount, right? That's going to be the future value of annuity, right? the present value of annuity is you have you want the lottery. Let's say you want the lottery, right? And if you lottery is usually, if you win the lottery, you have two payment options, right? Either lump sum or annuities, right? So let's say you won $10 million, but that's the jackpot amount. But then if you take lump sum, of course you get only after tax, which will be, for something like windfall gain. Lottery is a windfall gain, right? It's not earned income. They apply the top tax rate, which is 39%. Actually. So let's say about 40%. Then you get $6 million in lump sum, right? But if you choose annuity, right, you'll get it over like 30 years, monthly, right? And the monthly will be about somewhere around $20,000. I mean, interest rate is 6%, right? But question is it better? I mean, is it better? Is the annuity better or lump sum better? But it depends. It depends on the interest rate. You're afraid you're not going to leave at home. How old are you? I mean, unless you're like 60, I mean, you still have 30 years. I mean, and I don't think you're the type that would lead a reckless lifestyle, right? You'll live 30 years. Now, we have something called average life expectancy. So on average, you can be expected to live this, up to 81 or 82, or right? If you're above 60, if you're above 60, you can't. But as long as let's say you can, so then if the interest rate is high, right? If the interest rate is high, or whether interest rate is low or interest rate is high, depending on the interest rate, it can be different, right? Usually when interest rate is high, the lump sum is better. When interest rate is low, annuity would be better, right? Because how much it is discounted, right? When interest rate is high, all those annuity payments are $20,000 every month for the next 30 years. That's like 360 payments of $20,000. If interest rate is high, like 6% interest rate, all those annuity payments discounted to present value, right, will be much less than $6 million, right? But if interest rate is something like 1% a year, right, it gets discounted very little, and then it would be most likely greater than $6 million, right? So, but the annuity that, because it is present value, right? We'll need to use the present value of annuity formula, right? I think I should mute the video here. Or maybe so that because we are recording, I think I can use the. It's better to use what? The whiteboard, so it can be recorded. Where's whiteboard? Let me see. It seems like they don't have whiteboard here. Okay, let me use. I don't have. Still wants me to do this. Even one note? It's giving me such a hard time. Finally. It's such a Okay, and why is it taking so long? Okay, that one I used probably, so I'll get a new one. How do I get a new one? How do I get a new one? The bottom? Oh, add page. Okay, good. Thank you. And how do I get rid of? How do I? How do I get?
At the top right to make it bigger.
Where? I just.
Top right where the X is underneath to expand the whole page.
Oh yeah. You're great. Thank you. Thank you. So I should remember to bring a stylus next time. Once again, although what we need is present value of annuity, let's start with the future value of annuity. Basically, future value of annuity formula is payment times 1 plus r raised to n minus 1 over r. The second present value of annuity is payment over r minus payment over r times 1 plus r raised to n. Okay? But again, what we want is not the future value of annuity or, as I said, this is not what we want, what we need now. What we need now is this. Okay? Because we are dealing with the net present value, right? And what we want to know is the payment. We need to solve this equation for payment because this is known. We know net present value of, we can calculate net present value of the projects, project A and B. So the question is not the present value of annuities, but what kind of annual annuity payments, will that net present value generate? Okay, and whichever generates greater is better. That's what's going to be selected. So okay, I move it with the finger. Okay. So then next question. This formula needs to be transformed, right? This formula needs to be transformed because the way it is now, this is basically a formula for formula to solve for present value, right? So we need to transform it to solve for payment. So then to do that, we will need to factor out the common factor. So you might think, oh, the common factor in these two terms is payment over R. Yes, payment over R is the common factor, but if you factor out like payment over R, this one will become 1, and this one will become 1 over 1 plus R raised to n, right? But then this will we don't need to bring it to even to this point, because what we need is only payment. So we can only factor out payment instead of doing this. So in other words, I don't want to erase it, so it's going to take time. So I'll just, instead of doing this, right? Not that is wrong. How do I? Oh, undo. Yeah, you're right. Thank you. I haven't used OneNote for a very, very long time. I've been using only the whiteboard. Maybe I can also, since I recovered my password, maybe I can. But anyway, so not that this is wrong, but we don't need to, we can only factor out payment. So if I factor out only the payment, it's going to be payment over, times 1 over R minus 1 over R times 1 plus R raised to n. Right? Mathematically, I think this is not that difficult to follow. Now, always remember the equal sign, it continues. Equal sign makes this formula, left-hand side of the formula to continue on, right? It's basically present value of annuity is equal to this, which is equal to this, which is equal to this. So don't forget we have left-hand side, right? And then inside the bracket, we can simplify what's inside the bracket, which is, using the common multiplier, and the common multiplier between the two is R times 1 plus R to the n. In other words, by multiplying 1 plus R, by multiplying 1 plus R to the n here, right? And if you do that, you do the same thing to the numerator as well. So we unify or consolidate. We consolidate the denominator, and the this one becomes then 1 plus not that one. 1 plus R to the n. Nothing to change here, right? Because it was already like that. Now then, think about it. This is, and the left-hand side is what? Left-hand side is, if you remember, the left-hand side is present value of annuities, right? PVA. And then think about it. I don't know if I said this in this class, but in all other classes, I'm always saying, especially in Finance 100, I always say, a key to solving any equation, no matter how complex they may be, key to solving any equation is identifying z equals x times y structure, right? if you can identify z equals x times y structure, then if x is the unknown, right? Solving for x is easy, isn't it right? It's simply x equals z divided by y, right? It's like 12 equals 3 times 4. How do you find 4? 12 divided by 3, right? So then think about it. Do you see, where's my, do you see that structure here? Do you see that pattern here? Yes, the pattern is presenting itself right in your face, right? This is z, this is x, this whole thing is y. Isn't that right? So then, and our unknown is this. This is our unknown, right? This is our unknown. So then solving for payment, then payment is, then we'll have to divide PVA by the thing in the bracket. And we all know dividing by something is like multiplying by the reciprocal. And so we multiply the PVA by the reciprocal of the thing in the bracket. Then what is the thing in the bracket? The thing in the bracket is actually, you see it here, right? That's the thing in the bracket. And we multiply it by the reciprocal of that. The reciprocal will be then, I'll have to use a finger to move it. So it's going to be PVA times r times 1 plus r to the n, raised to the n, over 1 plus r raised to n minus 1, right? That's what, right? Just if you flip it. Okay, now we've found the formula for finding annual annuity payments. So we're going to apply this shortly. Oh, no, how do I? Okay. So I think I will have to, yes. So let's take a look at this example. The equivalent equivalent annual annuity method equates each project's original NPV to an equivalent annual annuity. For short-lived project, EAA is 167. On the same example, the equivalent of receiving 433 spread out over 3 years at 8%, while long-lived projects, so it's the same example. In other words, remember the net present value of project A, the project short was 432. So this is the present value of annuity, and we want to find what annual annuity it can generate for 3 years, right? At 8%. And this one, the present value of annuity is 867. So we need to find what is the payment, right? Annual annuity payment it can generate for 8 years, right? I mean for 6 years at 8%. So this is a graphical representation, but you know, graphical representation of net present value. And but we'll the summary is that this short-lived project will generate 167 annual annuity for 3 years each year, right? And then the longer project has 187 annual, right, annuity for 6 years. So then long-lived project will be picked. But we will need to verify that. Let's verify that. So we go to this, right? Did you all download this? And we go to, we'll go to this. Oh, this is not okay. Let me copy this. And so the numbers are slightly different, right? So we'll, I'll place it here and let's see. I can change the numbers, but let's do it here again. So I want to leave it as it is, and so what was the
1,500.
oh, is that right? Yeah, so it's, oh yeah, and 750, and everything has, okay, 750. So 1,000. We'll just change it to 1,500. And the other one is 260, right? Wasn't it
750.
Huh?
Yeah, 2,600.
2,600, right? 2,600. And then they all gave 750. Went through 750 for 6 years. Of course, we can do, net, we can find net. Oh, let's do this anyway. It's 8%, right? Not 10%. 8%. So then the present value will be simply, this divided by 1 plus, and D21, we lock it, right? You lock. And then, raise to, I'm sorry, I forgot to raise it to the years digit, right? And then you drag it down. And here the same thing. This divided by 1 plus that, and you lock it. Raise to 0, and we drag it down. And let's first find the net present value. Auto sum. Yeah, that's net present value. We auto sum this. That's net present value, right? Oops. And we're going to find internal rate of return later, but let's first see what is the, so using the, okay, why does it have underline? I don't need underline. Using the formula, right? What was the formula? If you remember, the formula is present value of annuities times R times 1 plus R to the n, right? Over 1 plus R to the n minus 1. So that will be exactly built in there. Equals, this is the present value of annuity, times open parenthesis, in the numerator, we don't need to necessarily do that, but r times 1 plus r raised to n. N is 3 in this case, right? Now the whole thing divided by, now we'll need to open another the outer parenthesis and inner parenthesis 1 plus r raised to n minus 1, close parenthesis. Okay? Now, let me draw the formula here on Excel. But to do that, I will have to hit enter first. So draw. Oh yeah, I can draw. PVA times r times 1 plus r raised to n over 1 plus r raised to n minus 1. Okay, so refer to that formula and it will be, so I got this. Okay, I'll have to close that. And then, what about the longer project B, let's say. Also apply that formula. That's the present value of annuity times r times 1 plus r raised to, this time n is 6, right? Because the second project has 6 years, right? Divided by 1 plus r raised to 6 minus 1, close parenthesis, and hit enter. There you go. Actually, I should, in this example, I should change the highlight. This should be yellow, this should be so this is exactly the result in the slide, right? The longer project, long-lived project generates higher annuities, right? So this one is better project. So it's like this. Suppose you won the lottery, right? 2 lotteries. I mean, what are the chances that you can win 2 lotteries? Not even once in your life. One is, jackpot is $10 million, but if you choose annuity, you will get it over 30 years. You won the second lottery, which has, let's say $5 million jackpot. Obviously, no, you cannot say. Obviously, you would go for 10. But let's say they generally pay similar amount, but one is longer. This doesn't make sense. I mean, forget about it. This example is weird because obviously for any lottery, you would, if you can choose only one, right? You would choose the one with a bigger jackpot amount, bigger, present value. That gives you bigger present value, right? Think of this as lotteries. If you won this lottery, the present value is like this, the present value is like this. But then you can collect all of those in 3 years, or you can collect all of those in 6 years. So then, in which lottery would you, and if you can choose only one, you want 2 lotteries, they say, oh, you want 2 lotteries, that's too lucky. We can't allow this. But you have a choice of one. Then which one would you choose? Something that generates bigger annual annuity, right? Something that generates, and that's the, and that's what, here, where was it? Yeah. Project short, its annual annuity would be 167.95, right? Project long, 187.58. That's exactly what we got here. Isn't that right? Also, you can do it this way. I don't recommend this necessarily, but you can use Excel's built-in function, right? Click function, right? And then go to financial category, financial, and it's in alphabetical order. So you scroll down until you find payment, P. It will be P, payment. Double click. Give it the rate. Give it what it's asking for. Give it the rate. Give it N. This one, for this project, N is 6, right? For project B, N is 6. There is no present value because this is annuity. There's no present value. Then future value, there's no, this one doesn't have future value. This one doesn't have future value, but this one has present value of annuity. So present value of annuity, this one, 8, this. Type, you don't need to enter type because type means whether it is ordinary annuity or annuity due. If it is ordinary annuity, you leave it blank. You leave it blank or enter 0. If it is annuity due, you enter 1. And I don't want to spend too much time on annuity due and annuity ordinary annuity, but in Finance 100 you learn this. And the only difference between ordinary annuity and annuity due is that annuity due has one more compounding than ordinary. That's the reason why you enter 1. If it is, but by default, unless otherwise specified, unless it is specifically mentioned that this is annuity due, by default, ordinary is default. Okay, ordinary is default. And also, in this, think about it, the cash flows are generated always at the end of the year. Isn't it right? Cash flows are generated always at the end. So it is ordinary. One more thing you need to remember is that if you do this, the result will come out as negative. Okay? But what does that mean? It means in financial calculator, cash outflow is always, cash outflow is negative. It doesn't mean it's negative amount. It just means cash outflow. Minus sign means cash outflow, right? So think about it. Actually, this is not cash outflow. This should be cash inflow, right? If it is annuity, this is annuity that you will be receiving, right? So it doesn't really matter because we have understanding that this is the equivalent annuity if we have annuity, right? But if you, so that means, so we know this is cash inflow, but you don't want this to come out as negative number. Now what do? all you need to do is basically, what was,
Put a negative over here.
yeah, this one, yeah, E30, we'll make it, put a minus sign, right? Then it will come out as positive, right? And you do the same here, you'll get the same thing. But I don't, I prefer, I prefer, I prefer, I prefer that you use the formula here, because, using Excel's built-in function is like, just entering data. I don't want you to become a mindless data puncher, right? You need to know what is going on, what is the mechanism, right? You need to know what's the mechanism, right? Yeah, question?
I'm about to leave because I have to go to my other class. I have a question
Yeah,
for
yeah.
you. What would business 210 be improved if I was to take it?
I don't know if they have equivalent course business. I don't know if
Do
they
you
have.
know what college offers? I need to take that class, unfortunately. You teach it in the summer, and I have to take it in the summer because I'm graduating in the fall. But the hours you have it for, I can't oblige to. They don't work with my schedule, so I don't know what to do. Do you know which college would offer me that class?
No, I don't think so. I don't think there's any CUNY within CUNY system. I don't think there's any Algebraic course business there. But it's gonna be online. I don't know, but you
Yeah,
still-
the thing is, because I'm gonna be at the bank, I can't be on my phone or the computer online.
All right.
So
Well,
I'll figure it out. Thank you.
all right.
Hopefully.
I have a question.
We'll have to do it. Yes.
Does down payment mean that the project is the equivalent of having a security that pays 187 in a for 6 years?
Yeah, yeah. I mean, for example, it's like this. If you buy an annuity plan, right, that pays you 187 every year for 6 years, then how much would you pay today? I mean, what should it be priced? Well, it would be 867. So if you pay 867 today, you're buying into this annuity plan. Over the next 6 years, we'll be receiving 187 every year. At the end of it.
And 867 is that's basically the present value of the project.
No, that's the net present value of the project. Net present value. So in other words, after deducting the initial investment, right?
I understand.
You're welcome. All righty. Any other questions? Any
Yes,
other-
I have a question.
Mhm.
In the equation, you put, n minus, oh, never mind. Never mind. Forget it.
Again, I'm not a big fan of Excel's built-in function. And why? Because it's like a black box, right? What's a black box? It's it's actually an orange box, right? That's what it's a flight data recorder, right? So usually, when airliners crash, then they dig up the site to recover the black box. Actually, bright orange, because it should be very conspicuous, right? It should be, if it is, really black boxes, it will be really hard to. But the reason it is called black box is nobody knows what's inside. But what's inside is actually, voice recorder. But it is in a very hard case, very hard metal. Why? If the plane crashes from 10,000 feet, right? It will be disintegrated. So it has to be a very hard metal case, right? Otherwise, it will be completely, you can't recover any data. But because it is a hard metal case, very sturdy, it's hard to open. You really have to. But think about it. Using Excel's built-in function is like, entering data into the black box. And then something goes wrong. If something goes wrong with that black box, you can't fix it. right? Because you can't touch the mechanism. That's why I want you to read from Excel's built-in function and use the formula. Because if you know the formula, that means you know the mechanism. If you know the mechanism, you can fix it. Something goes wrong, you can fix it. Right? All right. So that brings us to, and otherwise, some students get, I don't know why some professors use, they teach, Excel's built-in function. But then that turns the students into nothing but data entry personnel. Right? Not understanding anything, they just, bring up here, present value, right? And unless you become just the meaningless data entry, right, data puncher, right? Then you better use the, algebra, right? Better use the, and then, so that brings us to the conclusion of this topic. This is, graphic representation of replacement method, and next thing is capital rationing. Now, so obviously not all you remember there are 3 types of projects, right? Replacement, expansion, and new venture. And even if you are, just doing, one type of project, I mean, there can be competing, like, even for replacement, right? For expansion, there can be competing projects, right? There can be competing candidates, and they may be all good, right? Or, we need to do one replacement project and one expansion project and one new venture. They all have positive net present value. They all have positive, good internal rate of return that is above cost of capital. So then the problem is we want to accommodate all, but we have limited budget, right? All the companies have limited, budget. So we'll have to ration, right? We'll have to ration it. So used when capital funds for new projects are limited. Generally rank projects in descending order of internal rate of return and cut off at the cost of capital. However, this doesn't always make the best use of capital, so a complex mathematical process of constrained maximization can be used. A rough method. Okay, see. So we have our funds are limited at 60 million, right? Our budget is limited. And then we line up the projects in the order of internal rate of return and capital investment needed. So for example, what is this? Initial at time 0, initial investment that goes into it, right? Project A is the best, because it gives you like at least something like 16-17% return, and the company's cost of capital is 10. So ABC meets even D, project D. 4 projects meet that cost of capital criteria. E and F, no, right? Yeah. But then, even if they meet, if you put it in order, descending order, only project A and B can be accommodated because project A costs 8 million, project B costs 5 million. All right? Cumulatively 13 million, and our budget is 16 million. Capital C, it's good, but then it's 6 million. It costs 6 million, so we cannot make it. so it cannot make the call. So only capital A, projects A and B will be picked. Yes.
Why can't they just add project B?
It may fit, yeah. In other words, this one, it meets the, that cost of capital. This is like 3 million, right? So it will fit, yeah. You can have project A, B, and B. Right, it will fit, right? All right. Any more questions? Any more questions? All right, if you don't have any further questions, then we'll call it a day. And I will see you guys. Oh, don't forget, the midterm starts this Friday,
Okay.
right? All righty.
Thank you, Professor.
You're welcome.
Good evening.
You too. All righty, let me, where is it? Stop recording. All right, stop recording and